show that the total outer surface area of the barn, excluding the floor, is 2,034 meters squared, or square meters, if you prefer. Show the base of the triangle to be 18 meters and include all of the invisible edges. That will make our work simpler. If we include all of the invisible edges of the barn, also we'll show that the base of this triangle is 18 meters, being opposite to this side, which is 18 meters. 18 meters for this side, 18 meters for the base of the triangle, and we will include all of the invisible edges of the barn, so that when we are finding the individual areas, we can have a good visual representation of the faces, or we may say sides of the barn that we are addressing at this specific moment. The first area is the combination of a triangle, which is half base times height, and a rectangle, which is length times width. So we have the rectangle right here, which is, of course, this rectangle is 18 by 15 as we have represented there. And then we have half base times height. And of course it is color coded on this occasion to simplify the visual effects. There are two of them. We have one here and one hiding in the background, but it is not hiding anymore. We are highlighting it also. There are two of them. We multiply that by 2. The two sides are 25 meters by 15 meters rectangles. So this is one side, and then the other right there. One is always staring us in the face, and then the other one is a little bit obscured. No difficulty. We will highlight both of them. So 25 by 15, and we have a replica right there. So two of them, 225 by 15. What else do we have? Each inclined rectangle of the roof is 12 meters by 25 meters. We have two inclined rectangles. This is one of them. And then the other one is quite a bit out of view. But each of them is 12 meters, which is the slant height, by 25 meters, which is the length. That one, which is the one that is a little bit out of view, the one on the hindermost side is out of sight. Well, not entirely out of sight, but it's a little bit obscured. The one at the front is more easily seen, and when we put them together, then we even have a better view of the one that is a little bit out of sight. And each of them is 12 by 25, and we have two of them. On the next slide, we will have fun by using mental gymnastics combined with mathematics to simplify the resulting algebraic expression. Here we go. We have half 18 by 8. Half of 18 is 9, then 9 eighths, 72. That one is quite quick. Half of 18, 9, 9 eighths, 72. What about the other one? 18 by 15. What we are doing is treating the 15 as being analogous to 1.5. Like we are multiplying 18 by 1.5. 1.5 times 18. What we will do, we'll take 18 and add that to half of 18, as if it is 1.5. So 18 plus half of 18 is 27. But do not forget, it is not 1.5 but 15. So instead of 27, we should have 270. We have to recover the one place of decimal by which we reduced 15 to 1.5. So after reducing 15 to 1.5 by reducing it by one place of decimal, when we get the result, we need to increase that by one place of decimal. 18 times 1.5, add half of 18 to 18. Half of 18 is 9. 9 plus 18, 27. Recover the reduced decimal place by multiplying by 10 or increasing by one place of decimal. We have 270. Of course, that is multiplied by 2, no doubt. This one, well, I am going to depend on the animation to start me off on that one. 2 times 25 is 50, and then 15 times 50. That one is very simple. 15 times 50 is like 15 times 5, 75, and then the 0, 750. No problem. What about the next one? I'm going to depend on the animation or just go ahead. Well, I think that I'm going to go ahead of the animation on this occasion. 2 12s, 24. 25 times 24. Well, 25 and 4 are converse number. Whereas we are multiplying by 25, we may divide by 4 and make an adjustment. So we have 25 times 24. A quarter of 24 is 6. So that result should be 600. 2 times 12, 24. Multiplying by 25. Take a quarter of 24, which is equal to 6. Increase that by 2 places of decimal. We have 600, as I said before. And that is somewhat working with our mathemagics, which we have developed. Many different methods of simplifying arithmetic operations. Then, of course, we'll add those results together. Do not forget that we need to multiply whatever we have here by 2, and then the rest is history. Our final result is 2,034 square meters, or if you prefer, meters squared. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.